Welcome everyone. Short reminder before we start, please turn off your microphone and camera as the session will be recorded. You can ask questions later by either raising your hand or write them in the chat after the presentation. And now I'm really happy to announce today's MIU held by Adrian Falter, who is my colleague within the research project DIVMALDA. He works at Fraunhofer Institute for Software and Systems Engineering and gives us a short update on our DIVMALDA project about how digitalization can streamline emission regulation compliance. And the floor is yours, Adrian.
Thanks for the introduction, Anna. Yeah, today I want to speak about digitalization and on the other side also about emission regulation compliance. And these parts are combined in the project DIVMALDA, and I want to give you a short update on this. So let me give you a short motivation of a project. In general, as I think most of you know maybe, but I want to say it again. The IMO DCS and also the IMO MRV are both regulations that are based on some institutions that want to decarbonize the maritime industry, and since the IMO is on the international level and the EU is on the European level, they have different focuses, but in general we have similar aspects we go on, even though MRV is more tightened since they already implemented the costs for emissions, which have to be reported. But in general, each company or each ship has to report the fuel consumptions to ensure that transparency is given, but also to give these guiding mechanisms. These are the aims of the regulations. And the guiding mechanisms is transported by the costs. So the maritime industry, shipping industries or companies, they have to pay for the emissions they emit. And this has a guiding mechanism. Since they emit a lot, they have to pay a lot. And it is very important at this point that you have to report accurately, since the idea is that we want decarbonization, and therefore you have only to pay for emissions you emit, and in case you report too much, you pay too much, and that's not the idea of it, but also in the direction or the way around. So that's one point. And one other point is to not have too much effort or costs that coming with these reporting regulations you have. And on the other side, as I said before, you want this transparency and also these guiding mechanisms established to work against climate change, but with less effort and costs. And if you look at these figures I pointed here at the right, we shout up or we looked up to the EU MRV TETIS, which is the reporting database for the EU MRV. And there, if you take the container ships only that spend, I think, 2 months on sea, you see that they on average emitted 23,000 tons of CO2 or carbon emissions. And if you think about allowance price of 65, you get 1.5 million of euros to pay for a ship, which is a huge amount. And the idea is to be more accurate in our DIVMALDA project. I will present in the next slides more. And if you think about, you could be more accurate and also have less of these emissions because you are more accurate, you have a huge reducing effort. But honestly, yeah, it could be also other case around. But first, demonstration shows that, or first test shows that, it's positive for shipping industry. So that's the idea behind it, to reduce costs or efforts on the one side, and to be more accurate, which leads to this effect. So the idea of DIVMALDA, as I said before, on this big picture is to get these emissions from ships, and here we want to use the direct measurement to be more accurate. And since you use the direct measurement, you have already digitalized data, and this could be, or it would be nice if you have a completely digitalized data chain. And in this regard, you want to look at these data as a crew or as an analyst, and try to verify them later, or also report them, or let the stakeholders look at these data. And all this should be able with the DIVMALDA system. That's the idea behind it. And as I said before, digitalization is a important theme in this regard. So since the maturity level impacts also the effort and also the accuracy later. So you can think about how many correction cycles you need if you have a lot of manual data before, but also how quickly you can detect errors and also correct them. And I think also today you have a lot of these searching missing data topics that camps evolves too many times, I think so. And there we want these digital data chain that has no interruptions, or in general, and therefore you could be much faster and also less effort. That's one point. And the second point is that you could also build up other digital application on it. And since you have always a lot of barriers, this makes sense to have an digital or an effort at the beginning, but at the end you will be much faster in building up other applications. That's the idea behind that. In general, I want to speak a little bit of our chain behind the system. In general, we take different data sources into account. So, for example, here you have a direct measurement at an exhaust stream, and then you have also some other data here, for example, exhaust stream related data such as engine loads and so on, and also voyage data which you need to validate your direct measurements at the end, and you have to process them. So for example, take into account the outliers and so on, and since you do it directly after a collection phase, you ensure that you didn't have so much of these correction cycles. After that, you have the fusion and data preparation, and you need to harmonize and standardize it on the ship side. You have some infrastructure to do here, for example, data sharing, but also data persistence. And then you validate the data, correct them, and verify it with a verifier or by a verifier and report it. That's the general idea of it. And if you have these whole data chain digitalized, you may have some manual effort as well. So for example, with data validation will be also for difficult tasks to be handled by analysts, for example, or you have crew instructions there to do if some of sensors fails. But the idea is to be completely automatic. Let me make an endpoint on the standardization, since I think the standardization is one of the enablers of the digital applications. So since the standardization is the point which ensures the scalability, and here we have some points that are important on this, I think, and I think you all know them. So interoperability is one point, and also consistency, but I think the scalability is the major point on it. But if you look at the maritime industry, you have also different standards, and I picked up here two from the DNV pushed. As example given the operational vessel data, which is used for reporting, and also a VISTER standard, where you have also a name structure behind it, and you could take up all your data which is in your ship, or and you can access them. And I think this it will be used in the future in DIVMALDA, these standards. But I think these are the main points that make a difference to end up. And I think I'm maybe a little bit over time, but we can end it up on that part. If you have any questions, you can ask.
Thank you so much, Adrian, for your nice presentation. I think we can give the audience a few more minutes. If they have questions, just raise your hand or feel free to write in the chat. In the meantime, I have one question. Which parts of the framework are already currently automated within ships? Like which parts are existing and digitalized, and how can we address the still existing manual inputs?
Yeah, if you look at this picture again, you have already automatic data or automatic data integration in your land-based systems. Example given on the scrubber systems for a sulfur cut. There you also report already, or there is only the data chain ending in a persistence part, but you have also this automatic measurement of these, since there are sensors that measures the data. But if you want to look up, for example, here in this C part, where you have the whole ship-related data regarding, for example, voyage data, or also maybe the leveling of your bunker tanks and so on, there is a lot of manual data which is typed in by the crew and so on. So I think in the first line here in the A part, you have the most data which is already automatic. But if you go to the whole ship part, you have a lot of manual data as well.
Thank you so much, Anne. We already got a question in the chat. I will shortly read it to you because I think you can't see the chat right now when you're sharing. And the question is, have you done some field tests? If yes, how much improvement do you get with automatic data collection?
So how much? What do it mean with how much? But in general, accuracy improvement, or that would be or effort reduction. I think these are the main points. In general, at project part, we are on the case, or now trying to implement them all. We have also already data in a stream there, but yeah, the next steps would be to get these data and also have these validation part, for example, and also to make some experiments how accuracy could be improved, but also what are the impacts from these accuracy improvements. And I think that's the status of a project. We have a concept, we have also the implementation, but we have to do other stuff to integrate all these implemented things together and combine them and get these general statements we need.
Was more specified what is the difference between manual data and automatic data, and I think I can shortly add that it is planned to have 2 real-life installations, so one of a big container vessel which is currently prepared, and then one on a smaller port-going vessel. And I think the current difference between the manual collected data is that within the manual collected data often bunker tanks are read, and then again the data is not directly measured but usually just estimated with factors to calculate emissions later on based on fuel consumption. I hope this adds a little bit to your question.
Yeah, that's true.
Maybe to add on that side. Any further questions? Otherwise, thank you again, Adrian, for your nice presentation. And I want to announce next week's MIU. Next week, my colleague Niels will talk about CGLO and give an update on CGLO in German. CGLO addresses sustainable energy applications for green and low impact operation of small scale fishing boats. And I hope to see you all next week. And thank you so much and enjoy the weekend later on.